So completing the square is really about completing an actual physical square. Remember when we talked about how to expand and multiply using the empty rectangle? We did things like this. When we've set up our factors, we had x plus 1, for example, times x plus 2, and then we multiplied each of them and wrote the products in the boxes. So we'd get things like x squared, and then an x, and then a 2x, and then a 2, and then we would combine all the like terms and you get your factorization. So completing the square is exactly like that, except for we're going backwards. So we're going to look at filling in the square from our equation that we want to use. So the way we set this up is like this. So we've got x squared and 4x and 5, and this is a constant term here, so we're just going to put this at the end. We don't use that in our complete the square just now. We write a square, and we're going to use a little box in the middle there. These terms that we're already given, they're our products. So these things we're going to use are going to go actually into our box. So this x squared we write inside here, there's x squared, and then this 4x is the product and the sum of two different products there. So we're going to write that in the center. Now undoing this multiplication process is this idea of saying, well, what value times what value will give me x squared that's inside here? And we know that x times x is x squared. So that's what we can do for that first term. Now for this next term, this 4x, what we want to do is we want to actually halve it and put half in each box on either side. So half of 4x is 2x. So I'm just going to halve that and write that in both terms there. So now I'm still trying to construct what factors are existing on this outsides of the boxes here. So I've got here x here times 2 something, which will go here, equals 2x, which will go here. So we want to know what could that possibly be. In fact, we can see that x times 2 is 2x. Similarly, we can do that for this top line. Something here, x times something equals 2x, and that is also 2. Now this complete the square is actually, now we want to complete the square, and we're actually completing a square because here we have x plus 2 and x plus 2, so it's actually a physical square. They've got the same lengths on the outside. So we've got to complete this, finish this off here. So we've got 2 times 2 is 4, but we can't just add in an extra number. This number has been added. It wasn't from the x squared or the 4x or the minus 5, it's a new term, and we can't just add something in. We have to keep it balanced. So if I've added a 4 here, I need to remove that over here to keep it balanced. So if I plus 4 minus 4, I've kept the same equation. And now all I need to do is write down the actual factorization. So what I have out of all of this complete the square here is I have a square which is x plus 2 all squared. There's my square. And the constant term I have on the end here is minus 9. So that's my factorization, and I've completed the square. I've used the terms that I was given, and I constructed a square that had exactly those measurements within it. So that is my factorization.